Welcome to our lesson number 2, topic 2 in unit 1. It's about the subatomic particles and atomic structure. Okay, so last lesson we've learned about the atomic theory and how it came to be, and we've learned that there are essentially three subatomic particles. We got protons, neutrons, and electrons. But how do we know how to find those the amount of those particles for any element? So let's learn how to read a periodic table square so we can quickly find the number of protons, neutrons, and electrons for any element. Okay, so on the element square, you often have a symbol on the element. So for example, oxygen, the symbol is going to be O. And then the other one is the full name of the element. That's the element name, pretty obvious. And then we have two numbers. The first one is the atomic number. The lower number is usually on the top, and the larger number is usually on the bottom. The bottom number is the atomic mass. Okay, so the atomic number is like the ID number of the element. So for example, you have your student ID, we all have our driver's license ID, so everyone's number is different. Same thing for elements. Every element have their own atomic number, and those atomic number is determined by the amount of protons they have. Okay, so no two elements will have the same amount of protons. So for example, oxygen will always have 8 protons, or the atomic number will always be 8. And nitrogen will always be 7. Carbon will always be 6. So different atomic number means they have different numbers of protons. The bottom number is the atomic mass. That's how heavy the element is. And remember our lesson number 1, most of the mass is in the center of the nucleus. And what is in the nucleus? Protons and neutrons. Remember, electrons are on the outside, far away, right? So atomic mass is basically proton plus neutron plus electron all together, the whole weight of the entire atom. Okay. However, remember, the oil drop experiment allowed us to calculate the mass of electrons, and we found that electrons are super light compared to protons and neutrons. So right here, protons is about 1.67 times 10 to the negative 27th kilogram. And then neutrons is 1.67 times 10 to the negative 27 kilograms. And then electrons is 9.1 times 10 to the negative 31 kilograms. So this number is much smaller compared to proton and neutrons. Okay. So remember our scientific notation? That's like 3 decimal places. Actually 4 decimal places difference. Okay. So it's about 1,000th time smaller than those two numbers. And these two numbers are essentially identical. Okay. So the mass, because these numbers are so large, we don't want to write the scientific notation of these numbers to use as kilograms. Okay. So we've converted into something called AMU. AMU stands for atomic mass unit. It's a special unit made for these atoms because they're so tiny. Their weight will be different too. So for example, for us humans, we would use pounds or kilograms, right? For whales, we would probably use units like tons, how many tons they have. For atoms that are so small, we created their own unit. It's called AMU. So for atomic mass unit. So the atomic mass unit of proton is approximately 1. Is exactly 1.007. And then neutrons is also approximately 1. which is like 1.008. It's a little heavier than proton. And then electrons is approximately 0 because it's so light, okay? So you would assume protons are positive charge, electrons are negative charge, neutrons are heavier than protons. So does it mean that neutrons is actually a proton plus electron together? No, it's not. So neutron is its own type of particle, okay? It's not a combination of proton and electron. We can prove it by simple math. So if you grab your calculator over here and plug in 0.00054, 0.00054858 plus the mass of proton 1.007276 equals 1.007 something. It does not equal to 1.008665. Okay, so neutrons is its own type of particle. Is not a combination of protons and electrons. Because I used to think, when I was learning about this, I thought neutrons was just protons and electrons combined, so their charge canceled out to be neutral, but that's not the case, okay? So make sure you know that. Don't fall into that misconception. All right, next part, let's look at these numbers. So what is the atomic number of oxygen? Remember, atomic number is 8. Okay, let me change to a darker color. Atomic number is 8. So next one. This tells us oxygen have how many protons? Remember, the atomic number is equal to the number of protons. So if it has atomic number 8, then it must have 8 protons, okay? How many electrons? Remember, atoms are mostly, we're just going to assume that all of the elements are neutral for now. So if it has 8 protons, 8 positive charges, then it has 8 protons. That means we also have 8 electrons, negative charges. So they balance each other out, okay? So 8 protons, 8 electrons. How many neutrons does it have? So this one, we're going to need to do a little math. So for down here, we know the atomic mass is 15.999. We can essentially round this number to approximately 16 AMU. Okay, so let's do some math. So the atomic mass is the number of protons plus neutrons plus electrons, right? So remember, electrons are approximately 0, so we can pretty much ignore it. It's kind of like shaving your eyebrows. So if you walk onto a scale and you're 120 pounds, you shave off all of your brows, you're still 120 pounds. The weight of your eyebrows are so light, it doesn't really matter, okay? That's the case with electrons. Electrons are so light, we can ignore it. So we know there are 8 electrons, approximately 0 each. Protons are 8, approximately 1 each. Neutrons are also, we don't know the number of neutrons, and the mass is also 1 each. So let's do some simple math. 16 minus 8, which is 8, right? So again, when you're doing the math, I put this on here just to let you know the mass is everything, but we can ignore the electrons. You can ignore the electrons in all of your calculations. So the formula to find the number of neutrons is basically atomic mass. Atomic mass subtract the number of protons. Or an even faster way is to use the big number, subtract the small number, you will get neutrons. And then this number, the small number, is already equal to protons and electrons without any calculation. Okay, so to find the number of protons and electrons, no math needed. It's right there on the element square. If you want to find the neutrons, just use the big number, subtract the small number. Okay, the atomic mass minus the atomic number, which is the protons. Okay, so knowing this, you can pretty much find every particle for every element. So let's look at our periodic table. Okay, let's do aluminum, a common one. So again, our atomic number is 13. So 13, that tells us we have 13 protons. We also have 13 electrons, but how many neutrons do we have? So neutrons, again, is the big number. Subtract the small number. So let's round this to a whole number first. So 26.9, we can round it to approximately 27. So it's basically 27 minus 13 equals 14. So the number of neutrons for aluminum is 14. Okay, pretty easy. So let's do another element. For example, let's pick a big one. Let's do gold. So gold is Au. The atomic number is 79, and then the atomic mass is 196.97. So with these two information, we will know that it has 79 protons. It has 79 electrons. The reason why protons and electrons is always the same number is because protons are positive, electrons are negative. They always balance each other out. The whole element should be neutral. Okay, and then the neutrons is the one that you need to do some math. So right here, let's round it to a whole number. The nearest whole number would be 197. Okay, and then subtract that by 79. So pull out your calculator. We have 197 minus 79 equals 118. So neutrons is equal to 118. Oops. 118. Okay, this is how we find the number of protons, neutrons, and electrons for any element. And make sure you remember that inside the atomic models. So inside the nucleus is where protons and neutrons lay. And then electrons are on the outside as a cloud, right? So we have 79 electrons on the outside. We have 79 protons on the inside. And then we have 118 neutrons with no charge on the inside. So the mass of this whole element will have about 197 mass, because that's pretty much everything inside the nucleus. Electrons is approximately 0 AMU. Okay, doesn't really contribute to any weight. All right, so remember this: protons, neutrons inside the nucleus, electrons outside. Electrons doesn't really weigh anything. Protons and neutrons adds up to the atomic mass.